now I'm going to reduce this matrix, not all the way to the identity matrix, but to upper triangular form. Now we've already done that. We've already seen those steps for this matrix, and they're very similar for any other matrix. Of course, you adapt your steps to the matrix you have. This one turns out a little simpler than most because we get a free zero with one of our operations. So there aren't quite as many steps as there might be. Okay, and we're going to do this by elementary matrices. So we look at the matrix we have here, and we ask ourselves, what's the first thing we're going to do? Well, first thing people wanted to do, somebody mentioned at least, in reducing this, there are two good choices. One of them is to multiply this row by 1/2, so we'll get a 1 here. That's one of the things we want to get the upper triangular matrix. And I say upper triangular matrix, what I really want is upper triangular matrix with a bunch of 1s. Okay? So, multiply this by 1/2. What matrix would I use to do that? Well, I take the identity matrix and I multiply the second row by 1/2. This is the matrix I get. So multiplying this matrix times this gives us this. And again, I've got my multiplication written wrong here because I simply wasn't thinking. So this times this gives us this. And this times this will give us this. And this times this will give us this. And I'm not, you should understand that arrow's referring to the whole matrix, not just to the number 0. Okay, so you can verify. Multiply this on the left by this, and it's going to cut the second row in half. Okay, what's the next thing I want to do? I want to add -1 times the first row to the third row, because that'll give me my 0 here, and that's exactly what's happened. But I've done that by a matrix. Take the identity matrix, just 1s on the diagonals, add -1 times the first row to the third, and there's my new third row. If I multiply this by this, I get this. Now what I want to do? Well, I get upper triangular form if I simply do -1 times the second row added to the third. So, well, here's the identity matrix, but with -1 times the second row added to the third. If I multiply this by this, I get this. Finally, let's get a 1 here. Multiply the last row by -1/5. Well, here's what happens to the identity matrix if I multiply by -1/5. So this is my elementary matrix. Okay? And that gets me down to this form. Okay. Now what's very interesting here is I've effectively multiplied this matrix by what? First this one, then this one, then this one, then this one, and I've gotten this result. So that I can write the following. Let me get a completely new color here. I can say that if I start, I've got to give myself some room here, with my 1, 0, 3, 0, 2, 4, 1, 1, 0 matrix. And the first matrix I multiply that by is 1, 0, 0, 0, 1/2, 0, 0, 0, 1. That's going to have the effect of getting rid of that 1. And then if I multiply that resulting matrix, if I multiply these, I'm going to get this. If I multiply that on the left by this, it's going to give me this. So I've got my 1, 0, 0, 0, 1, 0, -1, 0, 0 matrix here. So if I do this product, it's going to give me this. Now if I multiply this on the left by this, I might have enough room to get 2 matrices in here. Okay. Well, I've got my 1, 0, 0, 0, 1, 0, 0, -1, 1. The matrix that subtracted the second row from the third to give me the 0 here. And now that product is this. And then finally I multiply by this. And my result is going to be this upper triangular matrix that we ended up with. Okay? Now, if I multiply by the inverses of these matrices, okay, if I was to multiply first by the inverse of this matrix here, then that inverse times this matrix would give me the identity, and then that times all this would just be all this, okay, from here on. If I multiply that by the inverse of this matrix, which is the inverse of this matrix, that's going to give me an identity here, which multiplied by the rest of this just gives me all of this, and so forth and so on. Now, I'm going to do that explicitly in a minute, but first we want to talk about how to get the inverse matrices, and then we want to talk about the order in which we're going to multiply them.